Assalamu alaikum wa rahmatullahi wa barakatuh. Our lesson today also to solve a problem related to Coulomb's law to find the electrostatic force between different charges or calculate the distance between charges or find the magnitude of the charges. Let's start with this question. In sodium chloride table solved, chloride ion have one more electron than they have protons. As you know, if the number of electrons greater than the number of protons, it means it's negative ion. If the number of electrons greater, it means negative ion. What about if the number of proton is greater? If the proton is greater than electron, it means positive ion. So that in the question, chloride ion have one more electron, so that a charge number 1, it's a negatively charged, 1 electron more, it means negative 1.6 multiply 10 to the negative 19 coulombs. And sodium ion have one more proton than electrons. Proton, it's mean positively charged. Q2 in this case equal positive 1.6 multiply 10 to the negative 19 Coulomb, because the number of proton is greater than number of electron. These ions are separated by a distance, separated by about, this is the distance between these two charges. Nm, it means nanometer multiply 10 to the negative 9. To convert from nanometer to meter, we must multiply by 10 to the negative what? Negative 9. Calculate the electrostatic force Fe between the sodium ion and the chloride ion. Positively charged and negatively charged, the force between these two charges is attraction or attractive force, because it's positive and negative. F1, it's equal in magnitude F2 and in opposite direction because they are unlike charges. Fe, it's equal K multiply absolute Q1 Q2 over distance square. The same charges, we can write the equation like that. K, we can write the formula K Q squared over R squared. So that electrostatic force, it's equal 9 multiply 10 to the power 9, it's K. Coulomb's constant, Q1 and Q2, 1.6 multiply 10 to the negative 19. We take the magnitude, 1.6 multiply 10 to the negative 19 squared. The distance is 0.28 times 10 to the negative 9 squared. Using your calculator to find the answer, fraction 9 into 10 power 9 times 1.6 into 10 negative 19 squared over 0.28 multiplied 10 to the negative 9 squared. The answer is 2.938. We can write it after rounding, 2.94 multiply 10 to the negative 9. 2.94 times 10 to the negative 9 Newton, and this force is attractive force or attraction force. The next question, calculate the magnitude of electrostatic force. Also, we need to find electrostatic force, it's Fe. Between two up quarks, the charge for one quark is 2/3 E. E is elementary charge. E, it's equal 1.6 times 10 to the negative 19. So that the two quarks or two charges, Q1, it's equal Q2 equal 2/3 times 1.6 multiply 10 to the negative 19. Inside a proton exert on each other if they are separated by this distance. Distance is R. What about Fm? Fm is femtometer. Femto is 10 to the negative 15. He gave us E, it's equal 1.6 multiplied into the negative 19 Coulomb, and the equation or the formula Fe K Q1 Q2 the same. We can write it Q square over the distance square, 9 multiply 10 to the power 9. Two charges are the same, 2 over 3 multiply 1.6 multiply 10 to the negative 19 squared over the distance square is 0.90 or 0.9 multiply 10 to the negative 15. Don't forget square. Using your calculator, Fe it's equal. I need you to see how can I substitute in the calculator. Fraction 9, then press this button, positive 9, multiply. There is two charges, each one is 2 over 3, 2 over 3, multiply 1.6 into 10, negative 19, then square over 0.90 times 10, negative 15 square. The answer is this number, SD 126.4, 126.4 Newton. This is the force between two quarks. Next question, a negative 4 microcoulomb, it's Q1 micro multiply 10 to the negative 6, lie 20 centimeter to the right, 20 centimeter to the right of other charge. So that Q1 and the Q2 microcoulomb also multiply 10 to the negative 6. The distance between two charges is 20 centimeter. Centimeter multiply 10 to the negative 2 to convert it from centimeter to meter. On the x-axis, what is the force on this charge? We need the force F or Fe, it's equal what? If I need to draw this situation in this problem, x-axis, we have x-axis and we have two charges, one charge at this point and the other charge at this point. Negatively charged lie on the right side, so that's the negatively charged will be here. This is Q1, it's a negative 4 microcoulomb, and the positively charged will be in the left, Q2, it's equal to microcoulomb because negatively charged lie in the right side of this positively charge. And the distance between two charges is 20 centimeter. As you know, we multiply it by 10 to the negative 2 to convert it from centimeter to meter. We need to find the force affixed on positively charged. As you see, positively charged will move to the right side. Why move to the right side? Because negatively charged will attract it to the right. This force due to charge number 1 on charge number 2. So that this force 1 on 2, it means the force due to the charge number 1 affects on charge number what? Number 2. This force will be to the positive x axis or positive x direction. We can use the formula of Fe equal K absolute Q1 Q2 over R square. K is 9 multiply 10 to the power 9. Q1 4 multiply 10 to the negative 6. Q2 2 multiply 10 to the negative 6. The distance centimeter to meter we can divide by 100 or multiply 10 to the negative 2 as you need. So that we can write it 20 multiply 10 to the negative 2 squared. Using your calculator, the force effect on the positively charged, it's equal to fraction 9 into 10 power 9 multiply 4 into 10 negative 6 multiply 2 into 10 negative 6 over 20 centimeter, 20 multiplied 10 to the negative 2 squared. The answer is 1.8 Newton. This is the magnitude. If you write like that, x hat, it means the force vector. It means the magnitude of this force, magnitude equal 1.8 Newton, direction of this force to the positive x axis or positive x direction.